Welcome to the Safety Modeling video for the Missouri Department of Transportation. This video corresponds with the MoDOT Engineering Policy Guide, EPG 905.3.6.2. Key takeaways from this module include the potential needs for safety analysis models, an overview of key safety models used in Missouri, where to find typical MoDOT calibration factors used in safety modeling, and the typical approach to completing a safety model analysis. Let's begin with an introduction of this video. There are two components of a safety study: an analysis of the roadway's crash history, and an estimation of future crashes. The focus of this module is on estimating future crashes with an emphasis on utilizing safety models. The following guidance is intended to serve as a resource for practicing MoDOT project managers and consultants when completing or reviewing TIAs when a future crash safety model component is included. These guidelines are consistent with the department's traffic safety standards of practice. Predictive safety analysis models are sometimes needed because historical crash data is not always available for TIAs. Existing data may not apply to future conditions, especially for new construction projects, and an evaluation of impacts from proposed geometric or traffic volume changes is needed. The safety models in this module estimate future crashes by utilizing Part C of the latest version of the Highway Safety Manual, HSM. The HSM is based on estimating crashes as predicted or expected. Predicted crashes are based on the geometry, volume, and national patterns of crashes, and are calculated within these safety tools utilizing standard safety performance functions, known as SPFs. Expected crashes are determined by adjusting the predicted crashes to include local crash history as a way to more accurately determine the modeled number of crashes. Now that we've introduced estimating future crashes using safety models, let's discuss a few key safety models typically used by MoDOT. There are 4 safety models typically used by MoDOT: MoDOT Crash Prediction Tool, Hsm Spreadsheets, Interchange Safety Analysis Tool Enhanced, ISAT-E, and Interactive Highway Safety Design Model, IHSDM. The Crash Prediction Tool developed by MoDOT is available for internal MoDOT use only at the time of this publication. It allows for the analysis of rural 2-lane highways only and provides the potential for safety improvements within a corridor. This is important because locations that could yield a high return on safety investments can be identified. For more information, discuss with MoDOT. The tool can be used for network screening and project analysis, and it utilizes Transportation Management System, TMS, data. The MoDOT Crash Prediction Tool also automates the analysis utilizing the HSM for the selected corridors so that it provides both predicted and expected crashes, and it provides the level of service for safety, LOSS. The Hsm Spreadsheets provide high-level overviews of the expected and predicted number of crashes within a study corridor. The spreadsheets require few input variables. The user must manually determine segmentation and other inputs based on Hsm guidance. The corridor should be divided into individual sites consisting of uniform segments and intersections. These segments should be no less than 0.1 miles to minimize calculation efforts and not affect the results. Roadway segments begin and end at the center of intersections or where the roadway segment changes. Currently, various spreadsheets have been developed by different sources. As of the date of this material, there are spreadsheets available for rural 2-lane highways, multi-lane highways, and urban or suburban arterials. Hsm spreadsheets do not analyze interchanges. ISAT-E, described in Hsm chapters 18 and 19, is a specialized spreadsheet analysis tool that was developed to analyze freeways. This includes the freeway segments, ramps, ramp terminals, and speed change lanes that comprise a freeway. ISAT-E requires more input variables than the Hsm spreadsheets. ISAT-E can be used for most freeway corridor types, though certain situations may require another tool. The tool can be used in conjunction with other Hsm spreadsheets if a local connecting road system needs to be analyzed as well. Segmentation of the corridor utilizing ISAT-E requires the user to manually divide up the corridor for entry into the spreadsheet. Each segment should be uniform with respect to traffic volume, geometric design features, and traffic control features. Key changes in characteristics such as the number of through lanes, lane width, shoulder, median width, ramps, or clear zone require a new segment to begin within the model. More information can be found at the MoDOT EPG on ISAT-E 905.3.6.2.5. IHSDM is a fully integrated safety modeling software with the capabilities of evaluating most types of facilities as an interconnected network. However, there are instances where Hsm Part C does not apply to a real-world situation and cannot be modeled. Refer to the Hsm Part C. The tool requires a high number of user-defined input variables. Using the Hsm spreadsheets as the core function of the modeling software, the IHSDM automates the segmentation process and provides a visual representation of what is being modeled. The user also has the option to import a land XML file containing the horizontal and vertical alignment information for every roadway, which can greatly speed up the development and accuracy of the modeling output. Now that we've overviewed common safety models used by MoDOT, we can discuss where to find MoDOT calibration factors. Parameters to be determined prior to completing an existing safety analysis include the following. MoDOT has a list of calibration factors that are available for reference in the MoDOT SharePoint library and are based on research documented on the MoDOT Research Publications website. The hyperlinks to these locations are available towards the end of this module under Additional Resources. The appropriate calibration factors should be utilized with these various modeling tools. The calibration factors have been selected to provide predicted and expected crashes that more closely correspond to real-world conditions in Missouri. Now that we've overviewed safety modeling calibration factors, we can discuss the typical analysis approach to overall safety modeling. Various sources have developed each of these tools, though they all utilize the HSM to conduct their analysis. It is important to determine through consultation with MoDOT the appropriate tool and tool version for a specific project. The same version of the approved tool should be used throughout the entire course of the project, unless instructed to utilize another version by MoDOT. Typically, the analyst should determine the future expected crashes and compare those to the existing expected crashes utilizing the appropriate modeling tool. This comparison approach allows for local crash characteristics to be taken into consideration when determining the effectiveness of proposed improvements. To determine the future expected crashes, the ratio of expected to predicted crashes under the existing condition should be determined and then multiplied by the number of future predicted crashes. This ratio can be utilized along with the future predicted crashes to extrapolate the future expected crashes. Professional judgment is needed to determine if one ratio is used for the entire project or if subparts of the project have and use separate ratios. Note that the ratio method works well for roadway realignments or other adjustments that are factored into the HSM analysis tools. However, those do not account for all situations, such as enhanced signage or roundabouts. Refer to the Crash Modification Factor (CMF) module for additional information for anticipated crash changes for different transportation facility types.
Additional notes to be aware of for future crash safety predictions include: the overall context of crash analysis results should always be considered. Future crash predictions are for total crashes, and the severity of these crashes should not get lost in the analysis. Always be mindful of the existing crash history when determining appropriate countermeasures. MoDOT has a goal of 0 fatalities on Missouri roadways. The plan to achieve this goal can be found in Missouri's Strategic Highway Safety Plan titled Show Me Zero. The crash risk factors and potential systemic safety treatments should be considered, even if a crash may not have occurred. For more information, refer to EPG 907.1.1 and Missouri's Strategic Highway Safety Plan.
Now, let's discuss key takeaways and additional resources. The revisited key takeaways from this module include the potential needs for safety analysis models, an overview of key safety models used in Missouri, where to find typical MoDOT calibration factors used in safety modeling, and the typical approach to completing a safety model analysis. In addition to MoDOT EPGs, more information can be found in MoDOT research publications, the MoDOT SharePoint library, the AASHTO Highway Safety Manual, and various MoDOT and FHWA sites on the safety modeling tools. Time to see what you know. Question 1. What is a potential reason that could contribute to the need for a predictive safety analysis model? Is it A, historical crash data is not available? B, existing crash data is not applicable to future conditions? C, an evaluation of impacts from proposed geometric or traffic volume changes is needed? Or D, all of the above? The correct answer is D, all of the above. Question 2, true or false? The 4 safety models covered in this module estimate future crashes by utilizing Part A of the Highway Safety Report. The correct answer is false. The correct statement is, the models estimate future crashes by utilizing Part C of the Highway Safety Manual. Question 3, true or false? Predicted crashes are based on the geometry, volume, and national pattern of crashes. Expected crashes account for local crash history to determine the modeled number of crashes. The correct answer is true. Question 4. Which statement is incorrect? The MoDOT crash prediction tool analyzes only urban arterials. Hsm Spreadsheets provide a high-level overview of predicted and expected crashes. ISAT-E is used to analyze freeways. IHSDM is a fully integrated modeling software that requires a high number of input variables. The correct answer is A. The statement should have stated, MoDOT crash prediction tool is used to analyze only rural 2-lane highways, not urban arterials. Question 5. What would be included in a typical safety modeling scenario? Is it A, existing predicted and expected crashes? B, ratio of existing expected to existing predicted crashes? C, proposed improvements to determine future predicted crashes? D, comparison of estimated future expected crashes to the existing expected crashes? Or E, all of the above? The correct answer is E, all of the above. Thank you for participating in the TIA Guidance Safety Modeling module. MoDOT encourages you to view the other TIA Guidance Learning modules. If you have any questions, please reach out to MoDOT Central Office, Highway Safety and Traffic.